Chapter 1.4 Functions. So our chapter goals are determine whether relations between two variables are functions and use function notation, find the domains of functions, use functions to model and solve real-life problems, and evaluate difference quotients. So let's look at what a relation and function are. So relation is a set or collection of ordered pairs. So let's look at specifically a function. A function f from a set A to a set B is a relation that assigns to each element x in the set exactly one element y in the set of B. The set A is the domain or set of inputs of the function f, and the set B contains the range or the set of outputs. So let's look at one example. Time of day to the temperature. So this is our domain, our inputs here, the time of day. So 1, 2, 3, 4, 5, and 6 p.m. Here are the temperatures in degrees Celsius. That is the output. So in really looking at relations and functions, so we're looking at number 1, at 1 p.m., it's 9 degrees, right? And at 2, it's 13, and so forth. Notice, in reality, at each time of day, you can only have one temperature, right? At 2 p.m., for example, you cannot have 13 degrees Celsius and 12 degrees Celsius. So it doesn't make sense. So it's a function if each input has exactly one output. Okay, so just kind of think about that in terms of temperature. So function, when it's a function, each input value is matched with exactly one output value. What's not a function is when any input value is matched with two or more output values. So for example, like our time of day, we can have two different temperatures. Just 4 ways to represent a function. You don't need to write this down. You can say it's verbally by a sentence, numerically by a table or list of ordered pairs, graphically by points in a coordinate plane, and algebraically by an equation in two variables. So let's try the first example, testing for functions. Determine whether the relation represents y as a function of x. So A, the input value x is the number of representatives from a state, and the output value y is the number of senators. So letter A, yes, that is a function. And of course, you have to know a little bit more about government, is that you have 2 senators in every state. It doesn't matter how many people you have in the state, that is always the same. So no matter what the x value is, the y value will be 2. And that's okay. So this, we're going to say, is a function. Normally, I won't give you very many of these that are worded in this way. Okay, letter B. Determine whether this is a function. So we have 2, it's a 2, 11, 2, 10, 3, 8, 4, 5, and 5, 1. So immediately we notice here that 2 has 2 different output values. So therefore, it is not a function. Now, if they were the same exact value, 2, 10, and 2, 10, then that's fine. But because they're different, this is not a function. Okay, letter C. We have x values of -2, -1, 0, 1, and 2, and there are no places that it repeats, so this is a function. Yes, a function. So go ahead and try these 2 examples down here real quick. So letter A, this is not a function. No, not a function, because -1 has 2 different outputs. Then letter B, we have 0, 1, 2, 3, 4, so we have no x values that repeat, so, and, with different y values, so then letter B, yes, this is a function. So next, we're going to test for functions represented algebraically. Determine whether each equation represents y as a function of x. So a equals x squared plus y equals 1. So in order to determine whether y is a function of x, we're going to solve for y in terms of x. So let's solve for y. So letter A, we're going to subtract x squared from both sides. So y equals 1 minus x squared. So each value of x corresponds with exactly one value of y, so this is a function. Okay, this is a function. If you think about the graph as well, and we'll get to that a little bit later, we know that the x values do not repeat with a different y value. Let's try letter B. So we're going to add x to both sides. We get y squared equals 1 plus x. And so if we square root y, 1 plus x, we're going to get y equals plus or minus the square root of 1 plus x. So in this case, because there's a plus and minus here, there are two values of y whenever you plug in an x, right? If we plugged in 2, for example, you would get, when x is 2, you would get y is root 3, positive root 3, and then you'd get negative root 3, right? So for the same value x, you get two different y values. So this is not a function. Okay, not a function. So we're going to try these two problems below to determine whether they are functions or not algebraically. So letter A, if you try that out, the letter A is not a function because you get plus or minus the square root. And then letter B, yes, that is a function because for every x value we get 1 y. The last thing we're going to do in this video is we're going to evaluate a function. Let g of x equal negative x squared plus 4x plus 1. Find each function value. So let me do a couple of examples here. We have g of 2, so we're going to plug in 2. So g of 2 equals negative 2 squared plus 4 times 2 plus 1. So this is going to be negative 4 plus 8 plus 1, or we're going to get 5. So g of 2 equals 5. Now let's plug in t. You're just going to do g of t, so we just substitute that variable. You're going to get negative t squared plus 4t plus 1. Now this is one we want to do. G of x plus 2. So for every x we see, we're going to replace an x plus 2. So let's try that. G of x plus 2 equals negative, not negative, you will get negative in the front, x plus 2 squared plus 4 times x plus 2 plus 1. Then you need to simplify. So this is negative x squared plus 4x plus 4 plus 4x plus 8 plus 1. Then you simplify further. Negative x squared plus, let's see, 4x, oh, that would be a minus 4x, sorry. Minus 4x minus 4, because I'm distributing the negative first, and then plus 4x plus 8 plus 1. So let's simplify all the way. Negative x squared, negative 4x plus 4x goes away, and then negative 4 plus 4 is 4, 4 plus 1 is 5. So g of x plus 2 equals negative x squared plus 5. So I want you to go ahead and try out these 3 examples down here. I guess particularly you want to focus on C. Make sure you could do that. So try this out. So if you tried this out, if you did A, f of 2, you would get negative 2. Letter B, you would get negative 38. And letter C, you would get negative 3x squared plus 6x plus 7. I worked out the problem at the bottom to hopefully help you out to see if you needed extra help. Thank you for watching.